What's up guys, and welcome to this tutorial. We are going over the 2017 IEB exam. We've gone through most of the questions and we're nearing the end. This is question 8. Basically it has to do with differentiation, points of inflection, a little bit of graph work basically. Okay, so let's get straight into the question. So this is question 8. Okay, so Susie is working on a function g which passes through the point passes through point 1 and 4. She differentiates the function and finds that the derivative g dash of x is equal to 4x cubed plus 3x squared. Okay, so question 8.1 says calculate the x coordinates of the points of inflection and state whether each is stationary or non-stationary. Okay, so let's start off by, we need to understand what this graph actually does or how it looks. And one way that we can do that is using our derivative function, because that tells us about our slope. So let's start off with 8.1. Let's start off with the function g dash of x is equal to 4x cubed plus 3x squared. Okay, and we can factorize this by taking out an x squared, and we're left with 4x plus 3. Okay, and then if we set this equal to 0, so let's say therefore x squared 4x plus 3 is equal to 0. Okay, so this tells us the important parts where there are sign changes or potential sign changes and changes in the derivative or changes in our gradient. Okay, so obviously x is equal to 0, so we can draw a nice number line at 0. So at the point 0, something happens, and at the point minus 3 over 4, something happens. Okay, so what do? We plug in a value. So if we plug in a value on the left-hand side of minus 3 over 4, so let's say we plug in minus 1, so we're left with minus 1 squared, which is a positive number, then minus 4 plus 3, which is a negative. Okay, so on the left-hand side we have a negative. Okay, if we plug in, let's say, minus a half, this value is always positive, this value here is always positive. This becomes minus 2 plus 3, which is a positive number. Okay, so we have a positive sign there. So basically there's a change in the gradient from a negative gradient to a positive gradient, something that looks, let's say, like that. And between, let's plug in a positive value. If we plug in a positive value into this function, everything will be positive, so we have positive, positive. So basically we have something that maybe looks like that. There's no actual change in the direction of the slope. So we can say that this would be a local minimum, and x is equal to 0 would actually be an inflection point. Okay, so if we actually wanted to calculate our points of inflection, what we need to do is now take the second derivative. So we need to calculate g double dash of x, and we can use a nice easy chain rule, which gives us 4x cubed would be 12x squared. So I just multiplied the exponent down and minus 1 from the exponent, and doing the same thing we're left with plus 6x. Okay, and we now can set that equal to 0 and factorize. So if we factorize it, we can take out 6x, and then we're left with x, or rather 2x plus 1, and we can let that equal to 0. So now we can say that x is equal to 0, or x is equal to this inside the bracket. We can solve that, and we have minus a half. Okay, so now at the point 0, we can see that there's no, so that's this point right here. At that point there is no sign change. So basically, therefore, we can say at x is equal to 0 is a stationary point. Okay, because there's no sign changes. Now if we plug in minus half, minus a half, that would be somewhere here, and here at x equals minus a half, we can say that it is non-stationary. Okay, so that's the answer for that question. So we can move on to question 8.2. Okay, so question 8.2 says, determine the algebraic equation of the function g of x. Okay, so we have, let me give myself a better space here. So we already know g dash of x, which is the derivative, right? And that was given as 4x cubed plus 3x squared. Okay, so to get g of x, what we need to do is integrate this. So g of x equals the integral of 4x cubed plus 3x squared. Okay, so integrating this, what we're left with, so we can say that g of x is equal to, so integrating this, so we need to do the opposite of differentiating, so we're going to be left with x to the 4, and we need to then, so that's exactly that, because if we differentiate this, that gives us what we wanted, which is 4x cubed, plus we'll have x cubed. Do we need something in front? Differentiating this now gives us 3x squared, which is what we need. But remember, we now need to add this constant plus c. Okay, so plus c. So this is also equal to y. Okay, and before we were given a point 1 and 4. So we can now substitute with the points 1 and 4, but we have the point 1, 4. Okay, so now we can substitute 4 for our y is equal to x, so 1 to the power 4 is just 1, and 1 to the power 3 is just 1, plus c. So we can say that c is equal to 2. So finally our equation would be y is equal to x to the power 4 plus x cubed plus 2. And that would be the final answer. Okay, yeah, and we get ourselves 6 marks for that. Okay, and then the last question is basically a theory question. Explain why a cubic graph will always have a point of inflection, but a quadratic graph, for example, may not. Okay, so for a cubic graph, I'm just going to dictate the answer. Okay, so for a cubic graph, the second derivative f double dash of x is linear, and therefore f double dash of x equals 0 always has a solution. So there's always going to be a solution for a cubic graph. However, for a quadratic graph, f double dash of x is quadratic, and therefore f double dash of x is equal to 0 may not have a real solution. So it may have imaginary solutions, therefore there's not going to always be a point of inflection for a quadratic graph. So I hope that makes sense to you guys. Okay, and therefore in total we end up with 17 marks. Okay, so just to run a summary quickly of what we did. So the first thing we did was calculate the x coordinates of the points of inflection. We had to state if they're stationary or non-stationary. So to do that, we first needed to understand where the graph would change its gradient or change the sign of the gradient. Then we calculated the second derivative and found that 0 is a stationary point and x equals minus a half is not a stationary point. Then we used integration to get the equation of our graph using the points 1 and 4, which was given to us. Okay, so I hope you guys found this walkthrough useful. We ended up with a total of 17 marks for that question. So yeah, thanks for watching, guys.